All right, now that we've looked at the IPv6 address and its format, let's take a look at the type of addresses that exist and some special types of addresses that we need to commit to memory. Now, the first one we're going to look at is something called the link local address. And basically with this address, all you need to know that it's an FE80. Do not concern yourself with anything else about this address. This address exists on every computer right now, every router. If you enable IPv6, this address will be present. If you were to go to your command prompt and do an ipconfig/all, you would see that FE80 address on there for as many NIC cards as you have. Whether you're doing static IP addressing or dynamic IP addressing, that address exists. There's a non-routable address. So it can only work if you're going to use it to network, you're going to do it within your own network. It's like it says there, it's the new APIPA. Remember the APIPA in IP version 4 was the 169.254 range. This is an FE80. Replace that. Remember, now we have neighbor discovery. So that comes into play. So every router's interface and every computer's NIC card will have that link local address of FE80. Now, there's something that says there about zone IDs. If you have a server, let's say, that is a multi-home server that has multiple NIC cards, well, since the address starts with FE80, when you try to ping another, let's say, FE80 address or another network to go out, how does it know where to go if all these addresses start with FE80? Well, there's something called a zone ID. At the end of the address, there's an actual percent and a number. So if you are going to ping an FE80 address, you're going to use that percent and the number. So you would copy and paste, and then you can ping. It'll be a lot easier than typing the whole thing out, trust me. So you would copy the whole thing to include that percent symbol so it knows exactly, because that percent symbol represents that zone, that NIC card of where it's going out to. All right, so that's your link local address, FE80. There is no other. The next is the unique local. These are your private IP addresses. FC, when it starts with FC, that is what you're looking at, all right? Some of them have gone, like FD. So normally, it's going to be from now on, it's FC00. Now, obviously, that 00 may change, but the FC does not. You will see an FC, if you do an IP config, or you do a show IP int, or show IPv6 in brief in your router, and you see an FC address, that means that, hey, this is a private IP address. That's all it is. And for your certifications, this is what you need to do to identify the IP address and what type of IP address it is. Multicast is pretty simple. FF. Anything that starts with FF is a multicast address. And we spoke on this earlier in the course where the routing protocols use a multicast address to send out their updates. And you can see the RIP is an FF02 with a :9. EAGRP is an FF02:A. And OSPF is an FF02:5. So you do need to commit those to memory, those IPv6 addresses, multicast addresses for the routing protocols, because I have a strong feeling that you may get asked that question. So, but again, if you see something with an FF, right off the bat, should trigger multicast. Now, we spoke briefly on Anycast addresses. There's the one to nearest. And we made the example that if you're in your home and you're trying to get to a supermarket and you have several public supermarkets near you, you're going to go to the one that's nearest to you. And when it comes to IP addressing, it's based on the routing protocol that you're using. If it's so many hops, if you're using RIP, or if you're using OSPF, it's because it's based on the cost. If you're configuring EAGRP, it's based on a metric. Lowest metric, lowest cost wins. Lowest hop or shortest number of hops would win. That will be the nearest to you because you're looking for that particular service, whether it be a web server, FTP server, or DHCP, whatever it is, if it's the nearest to you. That's what that Anycast address actually does. All right, and in order to configure an Anycast address, you can see here the syntax towards the bottom of the paragraph. You would actually put Anycast after the address, and that will go ahead and make it that IP address into an Anycast address. But besides these addresses, there's some special types of addresses that we need to know as well. All zeros. We've seen this. We've seen this in IPv4. We have the 0.0.0, which is the universal gateway, right? The gateway of last resort. That's what that all zeros is. Okay, so It still holds true for IPv6. Now, this is great, this next one. I love this because in IPv4, we have the 127.0.0.1 as a loopback. But in reality, the entire range, you can ping 127, 254, 251, 3, and it'll still come back with a reply because the entire 127 range was reserved just for loopback. But in IPv6, you only got one loopback address per interface. And that's it right there. : 1. You see how they truncated it? They took all those leading zeros and just put : We understand that everything in between those colons are zeros. Why write all those zeros? But for IPv6, that is your loopback. So how would you test it? Ping : 1, and you can ping your loopback address. That's what that means. So it's great. We don't waste IP addresses. Not that it's a much concern in IPv6, but still, you only have one loopback address. If you are working in a mixed environment using both IPv6 and IPv4, which this kind of syntax is kind of rare, you can mix both IP addresses by separating the IPv6 and IPv4 with a colon. But again, rare to see. Just know that you can do this. And the last one, if you see anything that starts with a 2000 or 2001 or even 2002, that's going to be a global unicast address range, which means it's public. And for the most part, everyone, unless it's a special circumstance for security reasons or what have you, that you don't have a global unicast, everyone will have a global unicast address. That is why NAT and IPv6 is going to be a thing of the past. We have NATPT in IPv6, but that is just a transition mechanism to allow us to still use NAT in our network since it exists, but it will slowly die away. It may take another decade, but definitely NAT is going away and we will all have global addresses. So there you go. These are your types of IPv6 addresses and your special addresses for IPv6 as well.